forward with the numerical methods, and we can continue by looking at this section of the trapezium rule. The trapezium rule, it is one of the methods of finding the area under a curve, or it is a method of integrating. In the little class, we will discuss methods of integration, but it's about the measure of trapezium rule. It is discussed in applied mathematics, but it is also a method of integration. So if you have the x and y axis, and this is the y axis, and you plot a curve of a certain function y is equal to f of x, and in this curve here you subdivide it into series of trapezium. This one approximates the trapezium, 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 and so many, and so many. So this one here means that you have scaled so many, and you come to this one. It is integrating. This is from A up to point B, and you're integrating. And this one here, you mark this one here. The length is y0, the length here is y1, the length here is y2, the length here is y. This one here, we can take it as yn minus 1, and that one here is the last. So this one is here. If the curve is something like that, if you find the area of this trapezium plus the area of this trapezium plus the area of this trapezium plus up to the end of the trapezium, if you add all those areas, you can get the total area under the curve. So if you're given the function, and you're integrating from point A up to B, the function f of x is x. This one is the same as h over 2 into y0 plus yn plus 2 into y1 plus y2 plus yn minus 1. Where y, it is this one here, it is the height of one of the sides of the first trapezium, and this one here is the height of one of the heights of the last trapezium. So and where the h is the same as the upper limit over the lower limit times n. This one here, the lower limit and the upper limit. So if we get the height in the formula here, it is h, which is equal to b minus a over n, where n is the number of strips or some intervals. Like for example, if you divide this curve into this is 1 sub-interval, 2 sub-interval, 3 sub, 4, 5, 6, 7. So means that here n is what? N is 7. If you divide the curve into 7 sub-intervals, this is 1 sub-interval, 2, 3, 4, 5, 6, 7. Those are the sub-intervals. So n is the number of sub-intervals which you will form in the curve. Then, if instead they give you the ordinates, the n is equal to the number of ordinates minus 1. Now, when you go back and make a reference to our curve here, the number of ordinates, and these are the number of lines. Like for example here, this is a strip or something, and this is 1, 2, 3, 4, 5, 6, 7. So means that the number of sub-intervals are 7. Now if the number of strips, those are the number of lines. I mean the number of ordinates. The ordinates, those are the lines which will make up what? The strips. So the ordinates, this is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 ordinates. So if you have to get the n, n will be the number of ordinates minus 1. Because you're going to 1, 2, 3, 4, 5, 6, 7. Those are 7 ordinates. 7 sub-intervals, 7 space. But if instead they give you the number of ordinates, like 1, 2, 3, 4, 5, 6, 7, 8, there are 8 ordinates. So if you're getting the number of sub-interval will be the number of ordinates minus 1. The ordinates, those are the lines. So we can see that this is the formula which you can use to integrate or find the total area under the curve. Now this formula is h over 2 y naught plus yn plus 2 into y1 up to yn minus 1. So we can use this example here, we can use this example to illustrate on how this formula can be used to find the total area and under the curve or to integrate. Like for example here, we are having the given integrate from 1 up to 4, we have the lower and the upper limit into x. This is integrating x plus tan x dx using 4 strips. So here they are giving us the number of strips or the sub-interval. The number, if you state this curve, it means that that curve was subdivided into, if you state this curve, it means that the curve was subdivided into 5 times, 4 strips, 1, 2, 3, 4. So the number of strips are 4. So by that one there, we are not really much interested in how the curve was divided because they have given you the number of strips that you should use. Then you use the formula, this formula here, and integrate using the 4 strips. And the question was correct. 2, 3 decimal places. So they have given us the condition that we should give our answer to 3 decimal places. So if you are integrating there, first of all, we need to get the a. We know when we're integrating from a up to b, the function f of x with respect to x, so it will be h over 2 into yn plus y naught plus 2 into y1 plus yn minus 1. So where h is equal to b minus a over m. So when we compare, when we try to compare with the upper lower limit, the b is the 1.4 minus the lower limit, which is 1, then everything over the number of strips. The number of strips, the number of strips are 4. Here a is equal to 4 because they said you should use 4 strips. So b minus a over n, so to be 1.4 minus 1 divided by 4. So you remain with the 0.1. 0.1, that is our value of h. Then what you do after getting the value of h, don't forget to get the upper limit minus the lower limit. Then after getting the value of h, you draw a simple mathematics, you draw a simple table. You draw a simple table. And this table will include the values of x and values of y. So for our y, this is what we are in the function which we are integrating, which is the x plus tan of x, that is the y. Then we will have the values of x here and their corresponding values of y. X and their corresponding values of y. X and their corresponding values of y. So now, when you are integrating, we are integrating from the lower limit here. Lower limit which is 1. So we start by writing 1 here. This is 1. Then after writing 1, the lower limit, you keep on adding. You keep on adding the h. You keep on adding the h. So 1 plus the h, which is 0.1. Remember the h is got from upper limit minus the lower limit. So h, you add 1 plus the h, you get 1.4. You get 1.4 plus 1.1. Then you get the h plus 1.1, you get 1.2. You get the h plus 1.2, you get 1.3. You get the h plus 1.3, you get 1.4. Now when you reach 1.4, which is upper limit there, you stop. Because when you reach the upper limit, you're integrating from 1 up to 1.4. So So when you reach 1.4, you stop there. Then what we do, we substitute. We have our function y is equal to x plus tan of x. Then you put y is equal to whatever there is x, you substitute 1, so it will be 1 plus tan of 1. And we substitute there. So, but strictly, since there is a trigonometric function here, a tan x, so which means we are using radians. So the calculator, we set radians. These are already radians. These are radians. Because if they are like 1 degree, that's why we will convert 1 pi over 180. But since they are going to put the degrees, it means that these values are already converted to radians. So for us, what we do here in the calculations, what we want to do, we still convert the calculator and we set it to radians when we are using the calculator. So when we use the calculators here, when we try to use the calculators, I'm substituting wherever there is x put 1, wherever there is x put 1, so you have 1. Calculator should be the radians. You have 1 plus tan of 1. Then you have your answers here. And you have it as 2.574. So you maintain a good number of decimal places. You can even add 1, because the more number of decimal places you use, the more accurate you become. And make sure that in your row here of values of y, the least number of decimal places you should use should be 4. When you use 5 and 6, that is better and more accurate. But you don't use 3 decimal places, 2 decimal places, that is inaccurate. So you use it 4 decimal places and above. So if we continue, wherever there is x, you put 1.1, 1.1 here, 1.1 there, then you use the calculator again. So when we use the calculator, we use the method which we have used, wherever there is 1.1 here, then you get the answer. Or to wherever the x put 1.1.1 there, you get the answer. Put 1.2, so when you use your calculator, but the calculator should be strictly set to radians, because you have a trigonometric function there. When you keep it in degrees on the screen of the calculator, if you bring on it is rad. Don't use it when it is in degrees. In numerical method, it is strictly, so you set your calculator to radians because of this trigonometric function. So when you come after getting all these values, now the first value, when you look at our formula here, h over 2, we will have the value of h already. So yn, y naught. So the first value here, the first value of it is the y naught. Then the last value, it is the yn there. The first value is y naught, the last value is yn. So this one here will be y1, y2, y3, and this is our n. This one here, this is our n is 4. So this one here will be y4, because from here we know that our n is 4 here according to this step here. N is 4. So this one here, the last value it is the yn. So when you come to substitute the formula, the integral from 1 up to 1.4, x plus tan of x dx. This one will be equal, we are substituting this one here, substituting this formula here. H is 0.1. Over here, this one here is the h, we already have it over 2. So this one here, it is the yn, which is the last value here, which corresponds to 1.4. Then y naught is the first one here, which corresponds to 1. So we come and substitute. We substitute wherever there is yn, we substitute the value of yn, which is 7.1979 plus y naught, and our y naught is this one here. The value of y corresponds to the 1, the lower limit, so which is 2.55741. Then plus 2 into. Now these other ones, y1, y2, y3, all of them, according to the formula here, all of those, but apart from the yn and y naught, all these other values, you add them and multiply them by 2. So this is 2 into 3.0648 plus 3.7722. then plus 4.9021. Then when you use your calculators here, when you do the math, you add these two values, then you add all these ones inside here and multiply them by 2. Then everything it is times 0.1/2. Then with this, the question was, we should give our answer correct to 3 decimal places, which means if you use your calculator very well, we will come up with the answer, which is 1.662, and the decimal places. I strongly believe that everyone is very conversant with the addition and multiplication here. What is the most important thing here is to know where is the y-n, where is the y-naught, and even knowing how to use this formula here. This formula here should not give you a lot of stress. This formula it is in the mathematical table. How to find the area under the curve, or how to integrate using the trapezium rule. So you can even just quote it directly from the mathematical tables. It is provided there. Then for you, what you do is knowing how to use and even following the rules, because they said we should integrate and give the answer to 3 decimal places. And most importantly, in this table here, the values of y here, you cannot use 2 decimal places, 3 decimal places, at least use 4 decimal places and above. Then it is the final answer, which is 1 to 3 decimal places. That's when we give to 3 decimal. But if the question did not specify the number of decimal places to use, then we will stick to a minimum of 4 decimal places for accuracy purposes. So we are still looking at examples where we can interpret using the trapezium rule. Now we are here saying that integrate from 0 up to 1, x squared times e is the product of the quadratic function and an exponential function. We're integrating with respect to x using 6 ordinates, and they're giving us an instruction that will correct our answer to 2 decimal places. So what we do, the principle is very simple. We say that if we're integrating from a up to b, the function f of x dx, this one when we are integrating it, it is h over 2 into yn plus y0 plus 2 into y1 plus yn minus 1 times 2 into y1 plus, it is only the first and the last two values of y, those are the ones which are multiplied by 2, but the rest are multiplied by 2. So when we try to compare, you know h is given as b minus a over n, and they have given us for 6 sub-intervals, for 6 ordinates. You said for 6 ordinates, a is equal to 6 minus 1, which is equal to 5. So a is the number of streets, or the number of sub-intervals. So when they give you 6 ordinates, means that the number of sub-intervals are 6 minus 1. We made that statement earlier. So which means that if you're obtaining our value of h here, h is b, which is 1, minus a, which is 0, over n, which is 5, and this one, our h will give us 0.2. So after obtaining our value of 0.2, now the rest is very simple. We go to our table of x and y. Go to the table of x and y. So we are having y, and y is exactly equal to x squared ex. So this one here will be x squared ex, that is our value of y. So here we are having values of x, then we are having corresponding values of y. So the values of x, we come here, the lower limit is 0. So we start by writing the lower limit is 0. Then after writing the lower limit, so then we keep on adding the h. Keep on adding this with h. So we'll add 0 plus 0.2 here. So this one will give us 0.2. Then we keep on adding 0.2 plus h, give us 0.4. Then 0.4 plus h gives us 0.6. Then 0.6 plus h gives us 0.8. And then we'll go to 0.8 plus h, that one gives us 1.0. So what we do, we have our y here. So what we do, we first substitute where y is equal to, wherever there is x, we put 0 squared times e power 0. On your calculators there, the e is there, the exponential function is there on the calculator, so you just press. So when you look at that function, wherever there is, so we are having x which is 0, so it will be 0. Then the 0 is squared, it is 0. Then the 0 is squared. You press your answer, then times the bracket. This bracket, that's where you put our e, the exponential function. And the exponential function, it is here. This is ln, where is the natural logarithm here, the calculator. Then you press the second function or the shift. Then you bring the e on the screen. Then e, it is also to power 0. Close the bracket, then you press the answer there. That's how you get that value of e. So this is 0, 0, 0, 0, 0. Look at the next value of substituting the x 0.2. You still do the same thing. You press the 0.2. You can even create a bracket for 0.2 squared. Then you close that bracket, you get your answer times. You press shift, then you go to ln. Then ln, it is power 0.2. Close the bracket, then you get the answer. So what you get, you maximize the number of decimal places for accuracy purposes. Like you can use like 4, 5 decimal places. So this one here will give us 0.0488. So if we do the same thing, we go to 0.4, still the substituting 0.4 here, square then times e power 0.4. You do the same thing, and when you use the calculator, look how we have used it, you come up with those corresponding answers. So we keep on substituting, because we want to substitute in our formula here where you have the yn and the y not and this otherwise. So the first value which corresponds to the lower limit, remember, our lower limit here is 0, the upper limit is 1. So the value of y corresponds to 0 is the y naught, the value which corresponds to 1, it is the yn. So this one here will be our y naught, y1, y2, y3, y4, and this one here, it is yn, the last value. So the integral from 0 up to 1, the function x squared, ex dx, this one equals, we are substituting here, substituting this one. Wherever there is h, we put a value of h which is 0.2, so it will be 0.2 over 2 into our yn is 2.7183 plus our y naught which is 0.0000, then plus 2 into 0.4886 plus this other one, which is 0.2387 plus this one, which is 0.65596 plus 1.42432. 432. So if we use our calculator very well and we're given instructions that we should give the final answer to 2 decimal places, but in our table here we maintain 4 decimal places or above, but after calculating here, substituting, you add this one, then you also add this one multiplied by 2, then you add everything, times 0.2 divided by 2. Then when you use your calculator, make sure that the answer you follow the principle, you follow the instruction that you should give the final answer to 2 decimal places. And when we use the calculators, the 4.75 and it's given 2 decimal places. So that's how we use the Trapezium rule to integrate. We can use another example here. For example, find the value of 10 degrees up to 25 degrees. F of x, sine of x dx, using 4 sub-intervals. Correct. 2, 4 decimal places. We know you have answer there. We correct it to 4 decimal places. Now, a situation like this one here, when we are using the Trapezium rule to integrate here, first of all, we first convert these ones here. We convert these ones here to radians. Convert to radians. So this 10 here, first convert the 10 to radians, so it will be 10 over 180 pi. Then this one here will give us it will give us, when this one will have pi over 18. Then we also convert the 25 and use 20 here, 20 degrees. So this one will be 20 over 180 pi. So this one here will be 2 pi over 18. That is being on the upper limit. You convert to radian. So you don't remove, you don't put the 22 over 7 here. You leave the pi there. You leave the pi. Such that when you are getting the value of h, it will be the upper limit, which is 2 pi over 18 minus pi over 18 divided by the number of sub-intervals, and the number of sub-intervals, they said we should use 4 sub-intervals. Then this one here will be, this is the 2 pi over 18 minus pi over 18. That one will be pi over 18 times 4. Will give us pi over 72. That will be our value of h, which is pi over 72. So we come and use now our y, it is equal to sine of x. So we draw, we have values of x, we have their corresponding values of y. So the values of x, we start by writing the lower limit. So now this 10 here, it is no longer, because now this 10 here, it is now a pi over 18. So you start with the pi over 18. Then you keep on adding, keep on adding until when you reach the upper limit. Don't forget here that these degrees are not used. So the lower limit, the upper limit is 10 over 18. So you get its value in terms of pi. The upper limit you get it in terms of pi. So our h, when you are getting the h, when you are getting the value of h here, the whole thing would have become pi over 18, then 2 pi over 18. That's how it will be, and we integrate inside x and dx, such that this one here, our a is pi over 18, then b is 2 pi over 18. That's how it would have been. So when you are getting the h, b minus a over a, since we are using 4 sub-intervals. So this pi is here. Don't create decimal places. Don't create decimal places. This h, pi over 72. Pi over 72. So you start with the lower limit, which is the 18, pi over 18. Then you keep on adding the h. When you add the h, you get 5 pi over 72. You add the h, you pass 6 pi over 72. Add the h, 6 pi over 72. Until when you reach the upper limit, which, and this one here, it is 8 over 72, which is the same as 2 over. Which is the same as 2 over 18 or 1 over 9. So when you reach the upper limit, which is 2 pi over 18, then you stop. And even you can calculate, you can even add. This is 1, 2, 3, 4. This is 0, 1, 2, 3, 4. And this one here, it is the yn. So when you reach the yn, which is 4, you stop. You stop. So the value which you get here, it will be y0, y1, y2, y3, y4. And this is the y4, since we're using 4 sub-intervals. When you reach y4, you stop there. You have reached the upper limit. Then you substitute, getting the first value of y, getting the y naught, you substitute. You have our function, y is equal to sine x, then you have sine of pi over 18. Then you get in the answer, you get the minimum of this formula. So you do the same after you substitute in the formula. So what I wanted to stress here, that this pi here, you leave it there for accuracy purposes. You leave it there.